Okay, good morning. Welcome to
Family Math number 161A.
Family Math number 161A. So, you're not feeling too well this morning, right?
No.
And you're excited to do math, right?
No.
So, what we're going to do instead of our little counting stuff today, we're going to do a fun little problem that James Tanton put on Twitter a couple days ago. I thought you guys would like this one a lot because it's a great example of problem solving, even though this problem's a tiny little bit over your head. It's maybe about here. Okay?
Yeah.
So the question is there an integer power of 1 plus the square root of 2 that has 1 million nines in a row after the decimal?
But the square root of 2 is irrational.
Right. But the square root of 2 is irrational.
That means but it's going to go on forever. After the decimal, it's going to go on forever.
Right, it is going to go on forever, but so what he's asking is is it ever like, I don't know, 211.9999 with 1 million nines, and after those 1 million nines, maybe it's like 21947, etc. Huh. So in other words, what he's saying is that does it ever get really close to being an integer? So do you see?
Yeah.
Do you see what he's asking? And you guys picked up right away on the problem. This is irrational.
Yeah.
So it's never going to be an integer. The power, we wouldn't expect it to be an integer.
Yeah, but it's going to get really close. Yeah, I remember a problem about pi and e that was really close to an integer.
Oh, really?
Yeah, I don't remember the equation, but it had like 29s.
Did it really?
Yeah.
Huh. I don't remember that. But yeah, that's pretty cool. So of course, there's this equation that has pi and e to the pi I plus 1 equals 0. That has pi and e and some integers.
Yeah.
Pretty neat. Okay, anyway, so let's take a look at this problem, and instead of trying to do the algebra on this all the way, what we're going to do is I thought this might be a fun one to go to the computer and look at it on the computer, because just the other day we had a question of sums like this: 2 plus 4 plus 6 plus 8 plus up to 2n, and 1 plus 3 plus 5 plus 7 up to 2n minus 1. We're trying to get formulas for those sums.
Yeah.
You know, how did we do that? What was the way we got familiar with that?
Well, we added up the numbers and saw if there was like any patterns.
Right. We looked at some smaller versions of just like 1, or 1 plus 3, or 1 plus 3 plus 5.
And these are squares.
Right. It turns out this one, when you look at those patterns, adds up to squares. And when you look at this one, it turns out there's a formula for it too. It's n times n plus 1, right?
Yeah.
And so instead of just trying to figure this out on our own, why don't we take the same approach on this and go take a look at what's 1 plus the square root of 2 as a decimal? What's 1 plus the square root of 2 squared? What's 1 plus the square root of 2 cubed? And see if we can see any patterns.
Alright.
Sound like a good idea?
Yeah.
I think that would be a good way to take a look at it.
Yeah.
Okay? Alright.
Alright.
Let's go to the computer.